Hello, my name is Alex Gonzalez. I'm here again trying to help you to understand how the data structures work. And then this time I'm going to be working with the stack. So I'm going to perform some operations such as create stack, pop, print stack, push, which pop and push are the basic operations and the free memory um, of the stack. So I have this skeleton already ready with no implementation of the different functions. Before we move forward, I move forward, I would like to share with you something personal that yeah. So in every video you can know a little bit more about me. My nickname is Kozlex, Kozlex. If you did Google as I asked in the previous video, you will find all my social media and stuff. And why is this nickname given it to me? Actually, I created myself, and that comes from Alex Coslex. The end of the last syllable is lex because of Alex, my name, and the first one is Koz, Koz, because this is a story where my grandpa asked me to go with him to visit a river, and he mentioned that there will be crocodiles. And in Spanish, crocodile means cocodrilo. So I couldn't pronounce pretty well. I had like 3 years old maybe, and I said cosdrilo instead of cocodrilo. So KOZ became my prefix of my nickname, so I'm Coslex. All my life, my family, friends, and my grandpa used to call me, or the ones that are still alive call me Coslex, and I'm the crocodile, if you want to say so. And I have a collection of crocodiles and many things around crocodiles in my life. So let's get hands-on what's the business about stack data structures. So what the first operations that I'm going to be doing, or the first operation is going to create, I'm going to create a stack with 10 elements, 10 nodes. As you see, I'm going to use a very simple struct node with only one pointer. There is two ways to see the stacks, and I've seen nodes about controlling the stack from the bottom and getting the pointers to the top, or getting the element on the top, having up the main pointer, and then going down into the stack. In my personal opinion, the best performance and the easiest way to work with this is to have the head of the stack at the top of it, and this is how I'm gonna be coding it today. So if you see it, it looks like a small single linked list, and kind of it is. It is kind of that, but I'm not gonna go into the pop and the push theory. But pop means extract, and push means add another element. So if you know a stack is just a bunch of things that are one on the top of the other. So to create the stack, I'm gonna be creating a loop. I love to use fors. FOR, that's what I mean. So in this for, I'm going to create a new node. And it's going to be malloc size of structure node. And as you know, I like to immediately set the node next to null, and the val immediately to I times 2. So if my if my head it's equal to null means that it's empty, right? And what I'm going to do is that the head it's now the new node, and that's it for now. But if it's not, I need to and I'm gonna do this. Usually I do it in a different way, but I'm gonna push the new node into the head. So it's already, notice this, that it's already a direct an address. I'm already getting an address and I'm passing the address. So that's why I'm not using the content of this. So this is going to reduce a little bit the number of lines of code, and to make the push, and I already have, oh, this push has a value, push by struct. Yeah, well, let's change the behavior of this, and then do struct node. So in that sense, we're gonna do the two operations already in one single pass. So I'm gonna do the push now. I was planning to do it later, but we can do it now. So this is gonna be this. So since the push actually this is kind of what I'm gonna do now. I'm gonna copy or cut and just say here push new node into head. So if head is equal to null, I'm gonna do the operation of adding this, and if not, what I'm gonna do is to position, since the head is already on top, as I said, I'm gonna make sure that the head is on the top. I'm gonna add the new node next. It's equal to the head, right? And in that way, my new element is gonna be, my new element on the top, or the head, is gonna be the new node, which means that I need to update head is equal to new node. And that's it, that's push. It's very simple, and the way that I'm doing it is because my last element, or the one in the bottom, is gonna be known as the one in the bottom because it's pointing to null, which means that the previous elements on the stack are gonna be on the top. So this is how I create a stack, and I'm doing it this. I'm doing it reusing or implementing the push immediately. And my push here, I need to change this because I decided to use struct node, a new node. That's what it is. So if I want to push, if I want to print the stack, I'm gonna do, I'm gonna need an index struct node index equals the one in the head, so it's there. And for index not equal to null, so I'm gonna print, well, index is equal to index next, and if index, actually, what am I doing here? I'm gonna say printf print I'm gonna print the value of that. And that's it. The null is gonna be the one at the bottom. I don't need to specify it because the determination of the pointer on null is gonna help me to do that. And I don't need to return anything here. Let me just add a fancy, well, not fancy, but printing. I change these every time, but that's fine. Okay, so similarly, the free that I'm going to implement right now, it's going to be using an index because I'm at the top, so I need to go to the next. Yes, struct node index equals to head, and I'm doing this just because head at some point is going to, I'm doing the full free or removing all the elements, so I can pass the address or not here of the head, but it doesn't matter. For index not equal to null, yeah, index equals to index next. Now here I'm gonna use index in the field next. I'm gonna use TMP that is gonna save the value of next, and then I'm gonna point index to the next element, to free for security purposes, to null, I'm sorry, for security purposes. And actually, since I'm moving the index here, I don't need it here, I'm moving it here. So I'm gonna free index and my temp, TMP, holds the value of the next in the stack, which means that I'm gonna move it, I'm gonna move it here, and index, if at some point it's null, that's it, it's over. So this is gonna help me to free the stack. So as usual, I'm gonna mention here printf. I'm just gonna add some comments for tracing. Index. Right. So yeah, I think that will be it for the case of the free stack. So I have implemented the push. I'm gonna remove the push from here because I'm not doing it over value, I'm doing it over an element that it's or a node that was already created. And finally, I'm gonna do pop. As you see, I'm having all the elements, and you don't need to know any value that you are gonna pop because you are gonna pop the one that is on the top. So you know the top because that's how I call it, the head. And to do that, I just need to free the one on top once and move my head to the next element. So I think I need an index, and that's what I'm going to remove, and that's it, because I'm going to move the head to the next one, and that will be it. So since it's already there, I'm going to say that head it's equal to head next, and if that is a null, sure, it's null, and that's it. The head is null, and that will be it. And I'm gonna my index, which is already There, the next element for security purposes, I'm gonna set it to null. I can also set it to 0, the val, which is okay. I'm gonna free it anyway, but for security purposes, I don't want any. Well, I forgot to do it just at below lines, so, some lines below, but it's okay. I mean, for this, it's okay. When you're doing real code, just keep in mind that it's better if you initialize to null the pointers and anything that you are using as the value as well. You need to free the memory or not let the real values stay there. So free index, and that's how we're gonna do the pop. Sometimes you want to do the pop and you want to return the element in the node and then do another operation, such as you pop it from this stack and you push it to a different stack. So it depends on what you're looking for. I'm not looking into anything else, so I'm just gonna do this. And I think that's all the code that I can do right now for this stack. Really quick. It was so quick. Let me take a look really fast here. I'm creating a new node. I'm setting to null the value. Then I'm doing a push, and the push is getting into the beginning of the list. If it's null, the head is updated, and if not, then I'm setting the new node at the beginning and updating the head, which is good as well. Looks good. Then I'm doing the print. I'm going to the first element, and then till it's not null. Then I keep moving. If it's not null, then it keeps moving, and then printing the values. Then I'm doing the free of the stack, which is moving in a temporal struct node pointer, whatever is next, and probably it's gonna be null. And then do the security thing, and then I just say that what's the value, and then I free, and then I update the index. And the index is already moved to the next element, and it continues to do its loop. So the pop puts the index in the first element, and then the head, it gets updated to the next in the stack. So it's just popping the one at the top, if you follow the logic that I mentioned, and that's it. So okay, so I'm gonna create a stack of 10, then I'm gonna print the stack, then I'm gonna pop the head, pop anything that is on the head. But when I do the pop, I'm gonna print, well, actually I'm not gonna print anything because I can print the stack again. And that's gonna show me that the first element that is shown, the first element that is shown here, the first node shown in this print, is not gonna be in this one. I guess that's it. So this file is named stack. I still have what I had before, cc stack in the output of stack. Okay, so number 42. Okay, so yeah, I need to do the parentheses here. 71. Index next. I think I'm missing something here. Oh, TMP is not here. No, TMP. It's two. And that's it. So, ta-da. So it's printing the 18th. It's printing. Yeah, it works. It works like a charm. That was so quick. I'm even surprised that it was so quick. So if you see, we have the elements. This was the first one created, and we went. If you see it as a stack, the one at the top is the one that is going to be popped, and it's not here, which is popped, extracted from the stack. And then when we free exactly what we were looking for, the 16, 14, etc. And you can see that the push worked as expected because when we were creating it, we're pushing things here. What are the use cases for stacks and lists and binary trees, etc.? I'm going to create another video specially created to add some examples of how you can use these data structures and where some use cases in real life that I have experienced and some others that I have known of or so. So hope you enjoy it, and see you in the binary tree video shortly.